Greetings everyone, Assalamu alaikum. In this brief presentation, I will demonstrate how to use the EDA playground that you will need for your exam. Since we are just gonna design a simple circuit using verilog and test it using a plain test bench, we won't be needing to use the cadence itself. So instead, we're going to use a lightweight solution. It's a web-based solution, which is EDA playground, and I'm just going to show you how to use it. So at first, let me search the EDA playground. So here it is. Uh, your, so I have already registered in the EDA playground, so that's why they're showing me this. But if it's the first time you're entering in this website, then you have to you have to register in it using your institution mail. After you have opened an account using your institution mail, this window should pop up. Okay, as you can see, there are two uh, two editors. This one is called the test bench, and this one is a design. SD stands for system verilog. Uh, since verilog is a subset of the system verilog, we don't need to change it. The system verilog will work just fine. So here, what do we need to do? After opening the account, you will have this setup, and here from the languages, I'm gonna select this system verilog. There are lots of other options, but I'll select the system verilog/verilog, and you don't need to touch these options. After this, I'm gonna go to the tools and simulator. From here, I'm gonna select open EPWave after run. So the purpose of EPWave is to show you the signals in a plot that we want to see after the simulation is done. And from here, I'm gonna select the cadence Zelium as my simulator tool. Okay, these options are okay. You don't need to change these options. These are okay as a default. Okay, now that the setup is done, and now it's time for us to write the codes over here. So in this side of your window, you should write you should design your device, and in this side you will paste your test bench. Since I will not talk about the codes themselves in detail. I'm just gonna use a example code. So for instance, I'm using the code for a counter. So I'm gonna just copy this code and show you how it's done. So this is the code for my counter device, and this is the code for the test bench. So I'm just gonna paste this test bench over here. So my code is done. After I'm done with the code, I'm just gonna run it by clicking here. It might take a few seconds. So you can see there's a error showing that no VCD file found, and they're saying that the EPROM will not open. As I've already mentioned, the job of EPROM is to show you the plots. So in order for it to be able to show you the plots, it needs a VCD file that contains all the signal data. So since I did not mention anything about it, the EPWave couldn't find any file. So what we're gonna do, they have already provided me with a suggestion of what to change. So I'm gonna copy and paste it over here. So now I'm telling the test bench that create a file named dump.vcd and paste all the signals in it. Okay, now my EPWave should be able to find the code and show me a plot of it. So if I run it again, so this is the graph. Okay, this is the waves. You can see that there are two copies of it. Okay, I don't need both copies, so I'm just gonna delete one copy. I'm selecting these two signals because they are repeated twice, and just click on this cross. Okay, if you want to change the signals further, if you want to add a new signal, just click on this get signal, select the code, and from here you can select any signal you want to show in your graph. For instance, if I choose the clock again, the append selector, so you can see there's another clock showing in the graph. So but I don't need it, so I'm just gonna delete it. Okay, you can zoom in your graph, you can zoom out, and you can change the presentations. For instance, in this wave you can see that the value of the counter is changing from 0 to 0, 1, 10, 11. Okay, if I zoom it out, so 0, 1, 10, 11. This is expressed in binary. So if I want to change it, I can change it to decimal. So you can see now it is 0, 1, 2, 3, 4, 5. I can also change it to hexadecimal. It's up to me how I wish to express it. So this is how you need to use this EDA playground for your exam, for your OEL. And what I want from you in your exam is, you have to, in your exam there will be have main two things to do. The first one is you have to design a device according to the specification mentioned in your question. After you are done designing it, you have to write a test bench. You may not have to write the full test bench. I might give you a template for it, but I'm not sure yet. So you have to write a test bench, and that will also be specified what kind of test bench I want. After that, you will run the code the way I have already shown you, and in your submission file, it has to be a PDF file, and it will contain all the codes, both the design and the test bench, as well as this graph. These three things is as all I expect from your solution, from your scripts. And yeah, that's about it. uh, if you have any question, just ask them in the classroom, and if I missed anything, let me know. Thank you.